Let's start with the basic problem. A model call does not automatically know what happened before it was called. It gets the current request, it reasons over that request, and it still produces something that sounds reasonable. But if the business decision in question depends on things like prior incidences or customer preferences or account information, these facts have to come from somewhere. They're not magically available just because a model might be smart. And this is the role that semantic memory plays. It is a way to make prior events queryable when an agent needs them. Instead of stuffing everything into the context of a prompt, relevant facts can be stored outside the prompt. They can be retrieved by meaning, and they can be brought back into the agent run as explicit context. The important part for production systems is that this retrieval is visible. You can see that the agent asked for memory, what tool was called, and how that affected the rest of the execution. So in this example, we're going to use a support escalation that is intentionally a little more realistic form of how this might work. Imagine Alice from North Star Robotics. She has a billing issue. Invoice 1042 is blocking a renewal, and the agent needs to decide whether this should move to a same-day priority. That decision depends on several facts: whether North Star is an enterprise customer, how much money is blocked, whether this invoice has already been escalated, whether finance approval is required, and how Alice prefers to be contacted. None of these are facts we want the model to invent. We want it to be able to pull them from somewhere. So let's look at the comparison of how it would work with and without semantic memory. Both agents would get the same user request. They'd use the same model. They'd have access to the same tooling, say billing priority policy. The difference is that one agent only sees the current request in the policy, while the other agent can first retrieve remembered customer context. And again, the goal is to see when durable customer context is available at decision time. It's not about which model is better. Here's the implementation difference. On the left, the baseline agent has the billing policy tool, but no memory tool. It's also instructed not to invent customer facts, which is critical. We want the agent to be conservative when it does not know something. On the right, the memory-enabled agent has a small semantic memory store and this recall customer context tool. In this example, the memory contains facts about North Star Enterprise's status, the disputed invoice amount, the renewal risk, things like prior escalation history, and Alice's contact preference. The memory agent can then retrieve those facts and then pass them into the same policy function as the baseline agent. So first, let's look at the run without semantic memory. This agent isn't broken, it still has a policy tool, and it still follows the instructions not to make up account details. But because it has no verified customer context, the best it can do is call the policy with unknowns, but then defer. On screen, we can see no memory execution. The run goes from the agent to an LLM step, to an evaluate billing priority tool, and then to the final output. The agent is able to evaluate policy, but the inputs it has are incomplete. Now we open the output, and the answer reflects that. It says the missing facts are account tier, renewal impact, invoice amount, and billing history. It also says that the safest next step is to collect those records before escalating. That's a reasonable answer for the information it has. It's not useful because it resolves the issue. It's useful because it refuses to pretend it has context that it doesn't have. Now let's run the same request with semantic memory enabled. The policy doesn't change. We're using the same model. What changes is that the agent gets a tool that it can use to recover relevant customer context before applying the policy. So here, the recall customer context tool appears before the billing policy tool. The agent is taking an extra observable step, retrieving customer context, then evaluating policy with that context. And then the retrieved facts are the ones the baseline run was missing. North Star is an enterprise customer. Invoice 1042 is a disputed $18,450 billing issue. The invoice is blocking renewal this week. The issue is already escalated once. And Alice prefers email updates rather than phone follow-ups. So now the policy tool has meaningful inputs. we open a priority billing escalation because of the enterprise SLA and renewal risk. But we do not issue, a write-off without financial approval. The final answer here also uses Alice's remembered contact preference, so the customer action becomes an email-based priority escalation and not some deferred we'll look into it and try to gather more information that might be presented without semantic memory. The point is, when an agent has to make a business decision, policy logic is only as useful as the state you feed into it. In the no memory run, the agent has a policy but no verified customer facts, so it falls back to a manual account check, hence the deferral. In the memory run, the agent retrieves 5 relevant facts, it applies the same policy, but it produces a more actionable path: priority queue, finance approval gate, and email follow-up. And this is the core idea behind what AgentSpan makes available. Agents are much easier to reason about when their decisions are grounded in visible tools, durable state, and inspectable execution traces. You can find the project on the AgentSpan GitHub or learn more at orcus.io/agentspan.